Hello everyone, welcome to today's video on logarithms. I'm Suraj Chawla, I'm a BCom graduate and I did my MBA from Xavier Institute of Management, Bhubaneswar in the year 2011. After that, I went on to work with ICICI Bank and worked for close to 1.5 years and also managed a portfolio of 400 plus crores there. Now it's been more than 10 years I've been successfully training and mentoring students in the field of CAT. I've trained 10,000 plus students from various backgrounds like BTech, BBA, BCom, BA as well as BSc students. Now a lot of my students have made it to the top IIMs including IIM Ahmedabad, Bangalore, Calcutta and also a lot of other top 40 B schools. Now in order to train my students effectively and also understand the patterns of the examination, I made it a practice to write CAT every year and I've been consistently scoring 99 percentile and above in the areas of QA and LRDI FCAT. So before we get into today's video, right, I would want you to subscribe to Apex CAT channel, like the video and also share the video amongst your friends who are preparing for CAT. So in today's video, I'll be discussing the concepts of logarithms and I also brought in the last 5 years questions on logarithms. And with each and every question we solve, I'll also be discussing the tips and tricks on how to make the question easy and also solve it successfully within the time frame. Now, why is this topic important? This topic is important as it is evident from the table that almost every slot we see at least one question coming up from this topic. And the other reason why this topic is important is it's a very small topic. So if you give good 2 to 3 hours, you should be able to safeguard 3 marks for yourself in the examination. So let's get started, guys. So let's understand what is logarithms here. So a logarithm is a power to which a number must be raised in order to get some other number. Let's not get into this. Now, suppose I have log x to the base b is equal to y. So we read it as log x to the base b is equal to y, where b is the base, right? Now, if I understand this in the exponents part, so b gets down here. So this becomes b to the bar y is equal to x. This is the basis on which logarithms has been made, right? So with the help of this, we have also seen a few questions which have come up in CAT. We'll also look at them. Now we need to understand that x also has to be greater than 0 and b also has to be greater than 0. Clear, right? So b should not be equal to 1 because the base of the logarithm can never be equal to 1. These are a few things that we need to keep in mind with respect to logarithms. Now, what are the properties of logarithms here? Now, the first property of logarithm is log 1 to the base a is equal to 0, because if I simplify this, I cross multiply, or this becomes a to the power 0, and we know that a to the power 0 is always going to be 1. So whenever I have 1 to the base a, it is always going to be 0. Similarly, log a to the base a is equal to 1, again a very important property. Whenever we see certain questions, our job is to see that we are trying to make the bases equal, because then we are able to eliminate the log. So please understand, whenever you get a logarithms, our major target is to eliminate the logarithms, right? So eliminating logarithms is the first basic way is, as we discussed, if I have log a to the base b is equal to x, I can eliminate logarithm by writing b to the power x is equal to a. This is the first rule of eliminating logarithms. Now this is one more way of eliminating logarithms, but more than this, this is the most powerful way of eliminating logarithms, right? Now let's look at the next one. So if I look at all the properties here, yep, so these are the different properties. Now, if I have log x to the power n base a, now this n comes out and gets multiplied here. So this becomes n log x base a. Similarly, if there's a power to the base a to the power m and x to the power n, then this becomes n by m log x to the base a. This is also a very important concept that we are using in a lot of questions in CAT. Similarly, if I have log x to the base a, that can be written as log x by log a. And one more formula we can attach to this is, if I have log x to the base a, and if I want to change the base, this can be written as 1 by log a to the base x. Okay. Similarly, log a x into y, log x into y base a gives me log x base a plus log y base a. And similarly, if I have log x by y base a, we get this as log a x base a minus log y base a. Clear? And again, if I have a power, a power log x base a is always equal to x, and I have a to the power log b is always equal to b to the power log a. right? Most of them are generally used. In fact, the last two are not generally used in the examination. We'll also look at how do we use the last two in a very simplified manner. But yes, the first few ones are very easy ones, very handy tools. Let's understand in the questions and let's try to apply. Clear? Now, this is the first question that we are looking at in today's session. So, I have log base 2 given something 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 is equal to 2 given, right? Now, the minute I see this, right, minus 2 is given to me, I can transpose minus 2, that becomes plus 2. So in this whole question, you won't believe, all I'm using is this concept. If I have log b base a is equal to x, then we are writing a to the power x is equal to b. Why does that come into your mind? Let's try to understand. So I can rewrite this as log base 2, I have 3, plus I have again log base 3 multiplied with 4, plus again I have log base 4 into x minus 1. Now this minus 2 I'm taking to the right hand side and becomes plus 2. Now if I need to eliminate this log gets eliminated. This becomes 2 square. Remember this? The log gets eliminated. This becomes a 2 square. So what do I have? I have a 3 plus I have a log base 3. Then again a bracket starts plus 4. Again log x minus 1 base 4. Now 2 square is 4. Let me write it as 4 here. Now there is a 3 here. All I can do is I can again transpose a 3 here. So I can write this as log base 3 4 plus again I have log base 4 into x minus 1 is equal to 4 minus 3, which is equal to 1. Again let's try to eliminate this log. If I eliminate this log, now this becomes 3 to the power 1. So we have 4 plus log base 4 x minus 1 is equal to 3 to the power 1. Or I can take a 4 this side. So this becomes, cancel a 4 here. This becomes 3 minus 4, which is equal to minus 1. So we have log x minus 1 base 4 is equal to minus 1. Eliminating the log, this becomes x minus 1 is equal to 4 to the power minus 1. Now what is 4 to the power minus 1? That is 1 by 4. Clear? So if I have x minus 1 is equal to 1 by 4, that means the value of x becomes 1 by 4 plus 1, which will be equal to 5 by 4. So this is the value of x that we get after multiple times of cancelling the log. Now what is asked in the question? The question has asked us find the value of 4x. So therefore my answer becomes 4 into 5 by 4. 4 and 4 gets cancelled, and therefore my final answer is going to be 5. So not a difficult question. We can see that on the basis of logarithms, we will be able to solve one of the questions. So whenever you see something of these lines, always try to cancel logarithms by taking the power on the right hand side. Clear? Now, let's understand this. So I have given two things. I'm given something log a here, I'm given something log b here, and the question is asking us the value of a plus b. That means we want the value of a, we want the value of b. Now let's look at the first part. I have log base 2, and in the brackets I have 5 plus log a base 3 is equal to 3. Now again, I can take a 2 here, make it a power. So let's cancel the 2 here. This becomes 2 cube, which is equal to 8. Clear? So I can write this as 5 plus log a base 3 is equal to 8. Now let's transpose 5 on this side. So this finally becomes log a base 3 is equal to 3. Again, let's cancel the log. If I cancel the log, this becomes a 3 cube. So I get the value as a is equal to 3 cube, which is 27. Now let's calculate the value of b here. Now to calculate the value of b, all that I'm looking at is I have log base 5 4 into 27 plus 12 plus I have log b base 2 is equal to 3. Now let's cancel the log. This log gets cancelled. This becomes a 5 cube. And 5 cube is equal to 125. So what do I have? 4 into 27 is 108. 108 plus 12 is 120. 120 plus log b base 2 is equal to 125. Or if I transpose the values, I get log b base 2 is equal to 5. Or eventually I get the value of b is equal to 2 to the power 5, that is 32. Now what is asked in the question? The question is asking us a plus b. So therefore the value of a plus b will be equal to 32 plus 27, and our final value here becomes 59. Again, we can see it's a very simple way in which we can apply the basic of logarithms and get our answer. Right? Let's look at the next question here. Now, what comes to your mind when you see this question? The numerator is not a problem at all. You have a 2 into 4 into 8 into 16. But if I look at my denominators have 4 and a base 2. So 4 and a base 2. Can I write 4 as a 2 square and a base 2 will be 2? That means I can convert this in the form of log a to the base a, and that is always equal to 1. Clear? Because you see the denominator everywhere, 8 and 4, 8 is a power of 2, 4 is also a power of 2, 16 and 8, 16 is also a power of 2, 8 is also a power of 2. So one we can apply here is log a base a, and the second one that we apply is if I have log a to the power m, and this is b to the power n, which can be written as n by m log b base a, or here in this case it will be log a base a, because everywhere I'm making the bases as 2 here. Right. So to simplify, let's try to understand this. So erasing this part, guys. Now let's try to understand this. So if I have log 4 base 2, I can write this as log 2 square base 2, and this can be written as 2 log 2 base 2. So 2 base 2 is 1, so that becomes 2. Okay, so let me write my numerator as 2 into 4 into 8 into 16. And my denominator, the first part log is eliminated, that becomes a 2 square multiplied with. Now let's try to understand log 8 base 4. Now 8 can be written as a 2 cube and 4 can be written as a 2 square. So this becomes 3 by 2 log 2 base 2. Now 2 base 2 is 1, here also 2 base 2 is 1. Clear? So this part becomes 3 by 2 whole cube. Similarly, we have log 16 base 8. Now this can be written as 8 can be written as 2 cube, 16 can be written as 2 to the power 4. So eventually we have 4 by 3 log 2 base 2. Again 2 base 2 is equal to 1. So this can be written as 4 by 3 whole to the power 4. So let's simplify this. So this can be simplified as 2 into 4 into 8 into 16. Now this 2 cube will go on the top, becomes 8. Now this 3 to the power 4 will be written as 3 into 3 into 3 into 3 divided by, I have a 2 square, I can write it as 2 into 2. I have a 3 cube, I can write it as 3 into 3 into 3. And I have a 4 to the power 4, which can be written as 4 into 4 into 4 into 4. Now let's cancel this up. So 3 3's will get cancelled with these 3 3's. 2 into 2 is 4, gets cancelled with 4. Now 8 2's are 16. Okay. 16 gets cancelled here. And this 16 also gets cancelled here. I'm repeating, this 3 is not getting cancelled. This 3 is left out. So finally, what do I have? I have an 8 into 3. That means my final value becomes 24. So you can see that our major priority in these questions, should be how to eliminate the log. Once we are able to eliminate the log, then it's a basic question of equations or exponents, and then we are able to get our required answer. Right? So let's move to the next question, please. Now, here I have log 0.008 root 5 plus log 81 root 3. 81 root 3 comes to our mind as something, 81 is 3 to the power 4 and root 3 can be written as 3 to the power 1 by 2. So that gives me a hint. Let's first simplify this. So I can write this as log 3 to the power 1 by 2 and this becomes 3 to the power 4. 81 root 3. Okay. So this becomes 4 divided by 1 by 2 log 3 base 3, which gets cancelled, and this becomes 8. So I repeat, this value gets simplified as 8. I am able to eliminate one of the logs. Now let's try to understand this part. So I have log 0.008 and this is root 5. Now let's first understand 0.008 is going to be 8 by 1000 and 8 by 1000 is nothing but 1 by 125. Now what is 1 by 125? 1 by 125 is 5 to the power minus 3. So this can be written as log 5 to the power minus 3 and this can be written as 5 to the power 1 by 2. which can be written as 1 by 2 divided by minus 3 log 5 to the base 5. Now 5 to the base 5 is 1 and this final value becomes minus 1 by 6. So we have been successfully, eliminating logs here. So I can rewrite this as minus 1 by 6 plus 8 minus 7, which eventually gives us minus 1 by 6 plus 1, which eventually gives us 5 by 6 as our required answer, and therefore the answer becomes 5 by 6. So I repeat guys, the best way to attack logarithms is pick up individual term of logarithms and try to see how do you eliminate the logarithms there, and then it's a matter of playing with equations only. Clear? Now let's try to understand this question here. So this is a standard question which you would have also seen in algebra. Okay. So let's try to understand this. So I can write this as p cube is equal to q to the power 4 is equal to r to the power 5 is equal to s to the power 6. Now whenever something is equal to something is equal to something, let us equate that to be k. So I can conclude here that p cube is equal to k. Let's write here. So if I write p cube is equal to k, I have to divide the whole thing by 1 by 3. So this gives me p is equal to k to the power 1 by 3. Similarly, we will have q is equal to k to the power 1 by 4. R is equal to k to the power 1 by 5. And S is equal to k to the power 1 by 6. So I've been able to eliminate PQRS in the form of k. Now why am I doing that? Because I have log S into P into Q into R. So if I log S is in the form of k and P into Q into R is in the form of k, that means I am heading again towards log A to the base A, and the value will always be equal to 1, and we will be able to eliminate the logarithms there. Clear? So I can write this as log, if I write S is k to the power 1 by 6 into P into Q into R, that is k to the power 1 by 3 into k to the power 1 by 4 into k to the power 1 by 5, which can be rewritten as log k to the power 1 by 6. If I have a to the power m into a to the power n, that can be written as a to the power m plus n. Clear? So which can be rewritten as log base remains as k to the power 1 by 6, and the main value here becomes k to the power, if I take the LCM as 60, that is 47 divided by 60. Now let's simplify this. So this can be written as 47 by 60 divided by 1 by 6, and then we can write log k to the base k. Now k to the base k is always 1. So this eventually becomes 6 ones are 6 tens are. So my final value here becomes 47 by 10, and that is going to be our required answer. Okay guys, so one more example where we are again using log a to the base a and we are trying to eliminate the logarithm there. Clear? Let's look at the next example here. Now, here, if you observe, everywhere the denominator has base as a different number, but the main number is 100. So, if every term has 100, now in logarithms, our first target is if base becomes same. If base becomes same, we can apply log same base x into y can be x plus y, or vice versa, and so on, so on, so on. And we know that if I have log a base b, this can be written as 1 by log b base a. Let's go reverse. If I convert this into this format, in every case, the value of base becomes 100. If I apply this logic, I can write this as log 2 base 100. Let me write all the plus terms together, plus log 5 base 100 plus log 20 base 100 plus log 50 base 100 minus, let me take a bracket common. Now this becomes log 4 base 100 plus this becomes log 10 base 100 plus this becomes log 25 base 100. This is my simplified term, and I've been successfully able to make the bases same. So if I have log A plus log B plus log C plus log D, which can be written as log base 100, and we can have 2 into 5 into 20 into 50 minus, I can again have log 100 base here, and this can be 4 into 10 into 25. Now 2 into 5 is 10, 10 into 20 is 200, 200 into 50 is 10,000. So this can be written as log 10,000 base 100 minus log 4 into 10, or 4 into 25 is 100, 100 into 10 is 1000. That's log 1000 base 100. So what do we have here? Now I can write the bases in the form of tens here, so that I can move towards log A base A. So this becomes 10 square, and this becomes 10 to the power 4, minus this becomes log, this is again 10 square, and this becomes 10 cube. Clear? So this can be written as 4 by 2, that is 2 log 10 base 10. Let me write it as log 10 base 10, which is 1, minus this can be written as 3 by 2. Again, I can write this as log 10 base 10. So 10 base 10 is also equal to 1. So my final answer becomes 2 minus 3 by 2. Now 2 minus 3 by 2 will eventually give you 1 by 2 as the answer, and therefore option B is going to be our required answer. Clear, guys? So again, a simple concept. We are trying to see either we are making the bases same. Once we are able to make the bases same, we are able to apply all the formulas. So these are a few ways to eliminate the logs. If I have to apply something, I need to try to make the bases same, or I need to use log A base A concept, and most of the questions will be moving towards those logics only, and we will be able to get our required answer. Clear? Now let's look at this. Now again, if you observe, I have log base 5 common. If I have log base 5 common, I can write this as log base 5. This can be written as x plus y into x minus y is equal to 3. I can cancel the log by taking an exponential. So I'm cancelling the log. This becomes 5 cube. So eventually what do I have? X plus y into x minus y becomes x square minus y square is equal to 125. So we already have this part here. Now let's look at the second part. In the second part also, the base 2 is common across. Clear? So what we can do is, smartly, I can write this as log base 2. Let me write this as y by x. And I'll smartly write 1 as log 2 base 2 minus log 3 base 2. So my left hand side is very simplifiably log base 2 y by x. On the right hand side also, I can take log base 2 common, and I can write this as 2 by 3. So I can see log base 2 will get cancelled. So we have successfully eliminated logarithms. That means I have y is to x is equal to 2 is to 3. So now I have a simple equations based question. Y is to x is 2 is to 3. So let me take y is equal to 2k and x is equal to 3k. And let's apply in this another equation, which is x square minus y square. So what is x square? That becomes 9k square. What is y square? That becomes 4k square, which is equal to 125. Or eventually we have 5k square is equal to 125, or this becomes 5 ones are 5 25s are. Or we have k square is equal to 25. Now what is the question asking us? The question is asking us the value of x into y. Now the value of x into y will be equal to the value of 2k into 3k. What is 2k into 3k? That becomes 6k square. And we already have the value of k square as 25. So this becomes 6 into 25. And therefore our final value here becomes 150. And therefore 150 becomes our final answer in this question. Clear? So again, strategy remains simple. Look at the approach towards each and every question. Don't just blindly apply formulas. Right? Always the standardized approach should be, how do I eliminate logs? So we are seeing one more step ahead, where we are able to see that if log 2 and log 2 is common, we can cancel both the logs and we can eventually get the value there. Clear? Let's look at this question. Now, under root of this, and I'm told x is a real number and this number is also a real number. Now, we should always know that if square root of some number is a real number, then this whole part should always be greater than or equal to 0. So I can simplify this as log some base, which is 4x minus x square by 3 should be greater than or equal to 0. Now to eliminate the log, I can take e to the power 0. So I can simplify this as 4x minus x square by 3 is greater than or equal to. So now I can simplify this as an inequality based question. So this is 4x minus x square is greater than or equal to 3. Or we have 4x, or let me write it here. So we can write this as 4x minus x square minus 3 is greater than or equal to 0. Or I can multiply with a minus sign across. If I multiply with the minus sign across, this becomes x square minus 4x plus 3 is less than or equal to 0. So x square minus 4x plus 3 is nothing but x minus 1 into x minus 3 is less than or equal to 0. So we plot the roots on a number line. So my roots are 1 and 3. From the right hand side, we start writing positive, negative, and positive. And the inequality is demanding us to calculate less than or equal to 0. So therefore, our answer here becomes x is greater than or equal to 1 or less than or equal to, and less than or equal to 3 becomes your answer. And therefore, our answer here becomes option C. Clear, guys? So again, a very simple question, not a very difficult one. Only thing we need to understand is that if under root of something has to be a real number, then the under root value, the value under the under root should always be greater than or equal to 0. And base is always greater than or equal to 1. So base to the power 0 is always 1. And that is how we get our required answer. Clear? Now, let's try to understand this question. This question says log of something is the arithmetic mean of log of something. And if base is not given, we can assume the same base here. So let me rewrite this as an equation. If I rewrite this as an equation, so we have log 2 to the power a into 3 to the power b into 5 to the power c is arithmetic mean of 3 terms. Whole thing divided by 3. Now what is the arithmetic mean? So same log, this becomes 2 square into 3 square into 5 plus again log, if base is not given, we can assume the same base here. That is 2 to the power 6 into 3 into 5 to the power 7 plus again log, no base is given, so we can assume the same base, that is 2 into 3 square into 5 to the power 4. Let's cross multiply 3. So we get 3 log 2 to the power a into 3 to the power b into 5 to the power c is equal to, since the bases are same, I can write a log, that is 2 square into 3 cube into 5 to the power 1 multiplied with 2 to the power 6 into 3 to the power 1 into 5 to the power 7 multiplied with 2 to the power 1 into 3 square into 5 to the power 4. Okay guys, so I can rewrite this as log 2 to the power a into 3 to the power b into 5 to the power c whole cube, because this 3 gets come to the power here, which is equal to again log, this can be written as 2 to the power 2 plus 6 plus 1 multiplied with 3 to the power 3 plus 1 plus 2 multiplied with 5 to the power 1 plus 7 plus 4. So this log and log gets cancelled. So what do we have here? We have 2 to the power 3a into 3 to the power 3b into 5 to the power 3c is equal to, I have 2 to the power 9 into 3 to the power 6 into 5 to the power 12. Ideally, we don't need so much because the question is asking us the value of a, but I'm solving it so that in case in the exam, if some other improvisation comes, this is how we solve. Now, since I'm asked the value of a exists only here. So I have 2 to the power 3a is equal to 2 to the power 9, or I can simplify this as 3a is equal to 9, or 3 ones are 3 threes are. Finally, we get the value of a is equal to 3. So that becomes our final answer here. So if the question is asking us find the value of a, and therefore the value of a is going to be 3 in the end altogether. Okay guys, so let's move to the next question here. Now I have log 5 base 4 is equal to log y base 4 into log root 5 base 6. Clear? Now what can I simplify this? Let's try to understand. The base 4 and base 4 is common here. So let's write this as log 5 base 4 divided by log y base 4, which is equal to log square root of 5 base 6. Now understand guys, if I have log a base b, I can write this as log a base x divided by log b base x. Now x we can choose as per our convenience. So let me assume the value of x is equal to 4 here. So can I rewrite this as, this can be rewritten as log 5 to the base y is equal to log root 5 to the base 6, which is, let's say, equal to k. Now let's look at individual terms and eliminate the log. Okay. So if I look at the individual terms, log 5 base y is equal to k, or from here I get 5 is equal to y to the power k. Now let's look at the second term here. So I have log 6 root 5 is equal to k. So what do we get from here? We get root 5 is equal to 6 to the power k. But since I have 5 here, let's make this as 5. So if I need a 5 here, I need to square this part up. So this becomes 5 is equal to 6 to the power 2k. Now 6 to the power 2k can again be written as 36 to the power k. So in one case I have 5 is equal to 36 to the power k. In the other case I have 5 is equal to y to the power k. So we can equate y to the power k is equal to 36 to the power k. Since the powers are same, we can conclude that the value of y is equal to 36, and that becomes our required answer. So again, a very interesting question guys. Understand the approach. When the bases are same, bring them together. Right? Understand what is asked in the question. Look at individual terms. Try to eliminate the log. Try to equate the equations, and you see that you will be able to get your answer in the most easy manner. Here, let's look at the next question here. Now, this question says 5 minus log. That's a very weirdly looking equation here. Okay. Now, the best part is I have, how should I go ahead? Let's see. I have log root of 1 plus x base 10. Here, I have 1 by root of 1 minus x square. Can I write this as, I'm looking at only the right hand side part. Log 1 by root of 1 minus x square can be written as log base 10 1 by root of 1 plus x plus log base 10 1 by root of 1 minus x. Just look at the backward way around. If I take log 10 base 10 common, I write 1 by root of 1 plus x into 1 by root of 1 minus x. That will eventually give me 1 root of 1 minus x square. So I can rewrite now this as 5 minus, this can be written as log root of 1 plus x base 10 plus 4 log root of 1 minus x base 10, which is equal to, this can be written as 1 by, okay. So we can write this as, so we can rewrite this as 1 by root of 1 minus x can always be written as minus log base 10, or let me rewrite this as, one second. Understand where are we heading, okay? I can write this value as 1 by something can be written as log base 10 root of 1 plus x whole to the power minus 1 plus, again we can write this as log base 10 root of 1 minus x whole to the power minus 1, which can eventually be written as minus, I'm writing it here, minus log base 10 root of 1 plus x minus log base 10 root of 1 minus x. So this minus and this minus gets cancelled. Okay. Now let's transpose the values. So if this value comes on to my left, this eventually becomes 5 log base 10 whole root of 1 minus x is equal to minus 5, or 5 ones are 5 minus ones are. This can be written as log root of 1 minus x is equal to minus 1. Now let's cancel the log. This becomes 10 to the power minus 1. So we have root of 1 minus x is equal to 10 to the power minus 1, which implies root of 1 minus x is equal to 1 by 10. Let's square it up, which will give us 1 minus x is equal to 1 by 100, or eventually we have x is equal to 1 minus 1 by 100. Now what is 1 minus 1 by 100? 1 minus 1 by 100 gives me 99 by 100. Now we get the value of x here, and the question is asking us find the value of 100x. So therefore the value of 100x here becomes 100 into 99 by 100. 100 gets cancelled, and finally the value that we get here is going to be 99, and that is going to be our required answer. Okay guys, so this is how we again solve slightly complicated questions given to us, right? And then we simplify to see how do we get our required answers, right? Now let's look at this question. Now I have x is a positive quantity, and we are given that 2 to the power x is equal to, now whenever you have powers, okay, I would suggest the best way to do is apply log on both the sides. If I apply log on both the sides, I would get log 2 to the power x, which is equal to log 3 to the power log 2 base 5. Now this can be written as x log 2, clear, is equal to log 2 base 5 into log 3. Now since base is not given, we can assume a base. So let's assume a base as 3. So this base becomes 3, this base becomes 3, this cancels to become 1. Clear? So what do I have here? I have x is equal to log 2 base 5 divided by log 2 base 3. Clear? Right? Or we can write this as x into log 2 base 3 is equal to log 2 base 5. Clear? Right? Now, here the base is, one second, 2 base 3, and I have 2 base 5. Cool, right? Now, what we can do is, I can make both of them equal to the same base. So, we can write this as x by log 3 base 2 is equal to 1 by log 5 base 2. Which we can rewrite this as x is equal to log 3 base 2 divided by log 5 base 2. Now we can rewrite this as log 3 to the base 5. So our value of x should be equal to log 3 to the base 5. So option A is not our answer. Clear? Option D is not our answer. Let's look at option B. Option B is 1 plus, we can write this as log 3 base 5 minus log 5 base 5. Now 5 base 5 is 1, plus 1 minus 1 gets cancelled, and eventually we get log 3 base 5. That means our answer eventually is going to be option B, and that should be our required answer. Okay guys, so this is how we get our required answers here, and this is how we should be able to approach, and we should be able to get the final outcome altogether. So whenever you have a power, the easiest way to solve is take log on both the sides, try to equate, try to make the bases same, and then move back. So this is also a very handy approach. Always remember, if you have log x, a base x, log b base x, I can always write this as log a to the base b. So if I have to convert in the final terms and you have to assume a base, we can always assume this as a base and eliminate our required answers. Okay, now let's move to the next question. Now this was one of the most interesting questions of logarithms so far, I would say, in the CAT history. Right? A few were very interesting ones or very difficult ones in the last 5 years. So this is one of them. right? Now let's try to simplify this. So I'm only given one part, that log 12, 81 base 12. So 81 can be written as 3 to the power 4 is equal to P, which can be written as 4 log 3 base 12 is equal to P, or I can write this as log 3 base 12 is equal to P by 4. Now I want to use P by 4. Now let's look at what is asked. 4 minus P. Can I write 4 minus P as, or divided by 4 plus P in the form of P by 4 can be written as 1 minus P by 4 divided by 1 plus P by 4. Clear? This is a very interesting way to look at it. So if I can write on these lines, I can rewrite this as 3 into 1 minus log 12 or 3 base 12 divided by 1 plus log 3 base 12. Now 1 can be smartly written as 3 into log 12 base 12 minus log 3 base 12 divided by, we can write this as log 12 base 12 plus log 3 base 12. The funda is simple, make the bases same. Now when the bases are same, log A minus log B will be log A by B. So this can be written as 3 into, this will give us log base 12, and 12 by 3 will give you 4, divided by, this will give us log base 12, and this will eventually give us 12 into 3. 12 into 3 will give me 36. Now let's take 3 here. So this becomes log base 12 4 cube divided by, this will be log 36 base 12, which will eventually be log 64 base 12 divided by log 36 base 12. Now the best part is log 12 can be eliminated by writing this can be written as 64 base 36. Now if I look at my options, I have 8 and I have 6. I can write 36 as 6 square. I can write 64 as 8 square. So this will eventually become 2 by 2. This is log 8 base 6. 2 by 2 becomes 1. So our final answer here becomes log 8 base 6. So this is a very interesting question, and therefore option B becomes our required answer, right? So this is how we solve our questions and we get our final answer. So we should be learning this kind of concept there. In case something in terms of P is asked, we can simplify and we can as well get our required answer. Okay guys, so let's move to the next question please. Now, real root 2 to the power 6x plus 2 to the power 3x into plus 2 minus 21. Let's write this as 2 to the power 6x plus, this can be written as 2 to the power 3x into 2 square minus 21 is equal to 0. Now I can rewrite this as 2 to the power 3x whole square will give me 2 to the power 6x plus 4 into 2 to the power 3x minus 21 is equal to 0. So I can see 2 to the power 3x common. So let me assume 2 to the power 3x is equal to k. And I want the real root. That means k has to be positive. Right? So if I simplify, this becomes k square plus 4k minus 21 is equal to 0. So which will eventually give us k plus 7 into k minus 3 is equal to 0. And therefore, we get the values of k as either minus 7 or plus 3. Now, minus 7 is not possible because I want the real value of k. So, therefore, we are assuming the value of k is equal to plus 3. Okay, so what do we have here? So, we have 2 to the power 3x is equal to 3. Now, if you see options are in the form of logs. Let's take log on both the sides. So, this becomes log this and this will also be log. So, we get 3x into log 2 is equal to log 3. Clear? Right? Now, we can again smartly look at this as 3x is equal to log 3 by log 2, which can be written as 3x is equal to log 3 base 2. Do I have log 3 base 2? Yeah, we have log 3 base 2 in the options. Now 3x is equal to log 3 base 2. I get the value of x is equal to log 3 base 2 divided by 3. So log 3 base 2 divided by 3. Therefore, option A becomes our required answer. Okay, guys. So again, a very interesting question in the form of quadratic equations plus application of logarithms. If you are able to apply quadratic, we should be able to get a required answer. Let's move to the next question. X is a real number and log 5 base 3 is equal to log something, which of the following is true? And if you observe, the options are given in the form of range. Now, let me apply this logic here. Can I say log 5 base 3 is greater than log 3 base 3 and less than log 9 base 3? So I'm giving a range here, right? So I can write this as that log 5 base 3 is greater than log 3 base 3 is 1 and log 9 base 3 is 2. Now since the right hand side is equal to this, so I'm writing this as log 2 plus x base 5 is greater than 1. Clear? And same log 2 plus x base 5 is less than. So to eliminate log, let's go this with us 2 plus x is greater than 5 to the power 1 or x is greater than 3. And again cancel a log. This becomes 2 plus x is less than 25 or x is less than 23. So I have x is greater than 3 and x is less than 23. Or in short, I can rewrite this as x is greater than 3 and less than 23. And therefore, option D becomes our required answer. And that's going to be our final value. Okay, guys. So this is how we simplify the questions in the examination, right? Let's move to the next question here now. Now, we have, okay. So we have 4 minus log n base 2 divided by 3 minus log n base 4 is less than 0. Let's first simply look at this as an inequality. Whenever I have inequality, the best part we do is we make the denominator as a perfect square by multiplying the denominator again. So I multiply the numerator with and I multiply my denominator. So this becomes 3 minus log 4 base n whole square. Now, if the denominator is a perfect square, that means denominator has to be positive. Clear? Right now, I have log n base 2 and I want to convert that into log n base 4. Clear? Now, just look at this for example. Can I write log n base 2 as log n by log 2? Now, since I want the base as 4, I multiply by 2 on both the sides. So this becomes 2 log n. Clear? Divided by, I can take this 2 here as a power, that becomes a 2 square. This becomes log 4. So this can eventually be written as 2 into log n to the base 4. So I can rewrite this as 4 minus 2 into log n to the base 4. There's one bracket. And again I have 3 minus log n to the base 4. Denominator is always positive, should be less than 0. Now what we can do? Let me assume log n to the base 4 is equal to x. So what do we have here? If I look at this value, so in a way I have 4 minus 2x into 3 minus x should be less than 0. Or I can rewrite this as 2x minus 4 into x minus 3 should be less than 0. So what are my roots here? My roots are 2 and 3. Positive, negative, positive. So therefore the range, which means log n base 4 should be greater than 2 and less than 3. So when I to go to the power, eliminate the log. So n is greater than 4 square, that is 16, and less than 4 cube, that is 64. So greater than 16 and less than 64, which means the total number of integer solutions, or I can rewrite this as n is greater than or equal to 17 and less than or equal to 63. So the number of integral values becomes 63 minus 17 plus 1. Now 63 minus 17 plus 1, eventually you have 47 integral values which will satisfy the given equation, and we will be able to get our required answer. Clear? So again, an interesting question. This was appeared in CAT 2022 slot 2. Difficult question, but yes, if you are able to apply basic ideas, we should be able to get our required answers. Now this is also one more interesting question. Now understand, if I have AB, A plus B by AB, we can always write this as 1 by A plus 1 by B. Clear? So I can rewrite this as 1 by log A base 15 plus 1 by log A base 32. Now 1 by log A base 32 can always be written as log 15 base A plus log 32 base A. Now the bases are same, so I can multiply. So this can be written as log A common 15 into 32. What is 32 into 15? That is 320 plus 160, that is 480. Now this is equal to 4. So we have 480 is equal to A to the power 4. Now A to the power 4 is equal to 480. So 3 to the power 4 is 81. 4 to the power 4 is 256. And 5 to the power 4 is 625. So I know that 480, so A to the power 4 lies somewhere greater than 4 and less than 5. Do we have an option? Yes, we have an option called greater than 4 and less than 5, and therefore that becomes our required answer. Okay guys, again a very interesting question to look at and get the required answer in a very simplified manner. So it's a combination of logarithms and algebra. So somewhere you need to have a slightly bent towards algebra. Keep your eyes and ears open to see that, how can I apply the logic? If I'm able to crack that code, then trust me, the game is going to be very easy for us. Now let's look at this. So I have log base A by B. So I can write this as log A base A minus log B base A plus, I can write my right hand side as log B base B minus log A base B. Now B base B is 1, A base A is 1. So what do we have here? So we have 2 minus, let me take minus common. You have log B base A and I have log A base B. To simplify this, I can write this as 1 by log B base. Now when I see log B base A plus 1 by log B base A, can I recollect something in the form of x plus 1 by x? Now x plus 1 by x is always greater than or equal to 2 or less than or equal to minus 2. Now if this value is greater than or equal to 2, let me assume, before this, let me assume this is equal to k. So if this value is greater than or equal to 2 or this value is less than or equal to minus 2. Now let's try to understand. If this value is greater than or equal to 2, then the value of k will be 2 minus 2 is 0. And then 2 minus 3 will be minus 1. That means the value of k is less than or equal to 0. Or if the value of k is equal to minus 2, 2 minus 2 becomes 4. Minus 3 will increase the value. That means it becomes greater than or equal to. Just apply minus 2 here and plus 2 here, and then we can get the value here. That means either the values of k should be less than or equal to 0 or the values of k should be greater than or equal to 0, greater than or equal to 4, which means the values of k greater than 0 and less than 4 will not satisfy. And that is what the question is asking you. Which of the following values will not satisfy? So any value between 0 and 4 will not satisfy. So between 0 and 4, we have only one value, that is equal to 1. So that is the only value which will not satisfy, and that will be our required. Clear? So let's look at, I guess, the last two questions of this session. Now, so why is a negative number such that again I have powers? Whenever I have powers, I told you already the logic is take log on both the sides. So we can write this as y square log 5 base 3 into log 2 is equal to log 3 base 2 into log 5. Right? Now, I can see a log 5 base 3 on the left hand side. So, the areas where I can assume a log, let me assume the base as 3 here. What is the advantage? If I take the base as 3 here, this portion and this portion gets cancelled. So, we have y square into log 2 base 3 is equal to log 3 base 2. Or I can write this as y square is equal to log 3 base 2 divided by log 2 base 3. Now log 2 base 3, understand this? Log 2 base 3 can be written as 1 by log 3 base 2. So this eventually becomes y square is equal to log 3 base 2 whole square. Or eventually we have y is equal to plus or minus log 3 base 2. Now it can't be plus because y is a negative number, is already told to us, which means we have to assume negative. So we are assuming y is equal to minus log 3 base 2. Now I can simplify this as y is equal to log 3 to the power minus 1 base 2, which can be written as log 1 by 3 base 2 becomes the value of y. So do I have 1 by 3 base 2? Yes, we have 1 by 3 base 2, and therefore option A becomes our required answer. So again, if you observe, the standard way of solving logs is a very simple log. You give one day to it, your job becomes easy. Yep. Simple formula is understanding the logic gives us the required answer. Now let's try to understand this last question. So this last question says I have log 30 base A is equal to capital A, and I have log 5 by 3 base A is equal to capital B. Now I have log A base 2 is equal to 1 by 3, which can be written as 1 by log 2 base A is equal to 1 by 3, or we can conclude that we have log 2 base A is equal to 3. Now why did I do that? Because if the first two are given in the base of A, I am also writing the third one in the base of A. Clear? Right? Now let's divide the first one and the third one. Let's divide the first equation and third equation. If I divide, what do I get? I get log 30 base A divided by log 2 base A is equal to A by 3. Clear? I'm erasing this part here, guys. That will help me to write. So what do I get from here, guys? So this can be written as A can be ignored. So I can write this as log 30 base 2 is equal to A by 3. Now which can be rewritten as log base 2. 30 can be written as 2 into 3 into 5, which is equal to A by 3. Or eventually what do we have here? We have log 2 base 2 plus log 3 base 2 plus log 5 base 2 is equal to A by. So 2 base 2 is 1. Clear? We'll come back to this later. Now let's divide first and second. Clear? Sorry, let's divide the second and third, not the first and second. Let's divide the second and third. So when I divide the second and third, I get what here, guys? Let's simplify this. So I can write log base 2. This is 5 by 3 is equal to B by. Or we can write this as B by 3 is equal to log 5 base 2. So this is minus B, my bad. So minus B by 3, and this becomes minus log 3 base 2. Now let's equate these two equations. Clear? So now if you observe in the options, we don't need a 5 base 2. Let's try to cancel a 5 base 2 first here. So this becomes plus, this becomes minus, and this becomes plus. So this and this gets cancelled. So we have, let's write it here because we will need space. So what do we have? We have 1 plus 2 log 3 base 2 is equal to a plus b divided by, or we have 2 log 3 base 2, I'm taking 1 to the other side, that becomes a plus b minus 3 divided by 3. This 2 can be cross multiplied, or I have log 3 base 2 is equal to a plus b minus 3 divided by 6. Now we are now coming close to our answer because the question is asking us log a base 3. Clear? Now if I have log 3 base 2, now look at this way, guys. If I have log 3 base 2 and I'm able to write this as log a base 2, can I rewrite this as log 3 base a? And I have log a base 2 as 1 by 3 here. Clear? Right? Right? So if I divide both of them here, so I have log a base 2 is equal to 1 by 3 here. So when you divide both of them, eventually we get the value of log 3 base a is equal to a plus b minus 3 divided by 2. Now I don't want log 3 base a, I want log a base 3. That will be inverse. So eventually we get log a base 3 will be nothing but 2 divided by a plus b minus 3. And that gives us the first option as our final answer. So again, a very beautiful question to look at, right? And simplifying the conditions are very important. Like 2 to 3 were very difficult questions. If you're able to understand the flow of those questions, trust me guys, you should be able to grab 3 marks in any slot in any of the CAT paper, because at least in last 5 years we have been seeing that logarithms questions definitely come up in the exam for sure, right? So that's it from my side, guys. I hope you guys learned a lot. Please like and share the video. Thank you. All the best and take care.